Morning, grade 7. Today we are going to take a look at learning about rates. So a rate is actually a ratio. So remember yesterday we looked at a ratio, and a ratio compares two different numbers. Now, a rate is a kind of ratio. So it's a very specific kind of ratio. So it's in the category of ratios, but it's special. It's different because it compares two different units of measurement. So the most common time when we would use a rate is when we're talking about the speed limit. So we say here that like maybe you're driving on a road in the country and you are allowed to go 80 kilometers in 1 hour. So we're comparing two different numbers, which makes it a ratio. But then it's a specific kind of ratio. It's a rate because it's two different units of measurement. We're comparing kilometers to hours. So yesterday in your textbook, you worked with ratios. You worked with finding equivalent ratios and simplifying ratios. But if you want, you can go back and you can take a look at that lesson and see if you can find any ratios that are also fit into the category of rate. Because some of them that you were working with compared two different units of measurement. So that's what a rate is. It's a ratio, but we have two different units of measurement. So let's take an example. So I don't know if you remember, I think it was like a month before Christmas, I did a lesson where I told you about my summer job where I worked at Premier Printing, and I had the job of putting a coil on the agenda. And then I had the choice to be paid per hour, or I had the choice to be paid per book, and that was called piecework. So in order to be paid per book or to make it worth it, I had to meet this rate. I had to be able to coil 300 books in an hour. That's an example of rate because again, look at, I'm comparing books to hours. It's two different things, two different measurements. Another time when you talk about rate is, let's say you get a job shoveling snow. Maybe your neighbor has a huge driveway and he agrees to pay you $20. So here's my measurement for 4 hours. Probably not the best deal, but you might accept it if you're really bored during this next lockdown. So those are two different examples of rate where we compare two different kinds of measurement. Now we're going to talk about a specific kind of rate, and that is a unit rate. So a unit rate has 1 as the denominator. So actually, let's just go back for a second. If we were to take a look at this snow shoveling example, you might think to yourself, okay, well, I get paid $20 for 4 hours. How can I figure out how much I get paid in 1 hour? That would be a unit rate because my denominator is 1. So grade 7, we're basically working with fractions, equivalent fractions. So you can ask yourself, well, what did I do to that 4 to get it to be a 1? I divided by 4. And then of course, remember to be fair with equivalent fractions, what you do to the bottom, you must do to the top. So I would divide by 4 here as well. And the rate that you would be paid, or the unit rate, because our denominator is now 1, is $5 for 1 hour. So that's an example of a unit rate. Now let's take a look at my example over here. This summer, my sister and I drove all the way from St. Catharines to Winnipeg because our flights home got canceled. So we decided to jump in the car and go on a very long road trip. So I just estimated, let's say that my sister and I drove 2,160 kilometers, and it took us 24 hours. It did indeed take us 24 hours. It was quite a long trip. I've never done one that long in my life before. Now, maybe you want to ask me, well, Ms. Nyhoff, if it took you 24 hours to go 2,160 kilometers, what was your rate, or how fast were you driving on average? So again, what we're doing is we're looking for that unit rate. You know how far I went in 24 hours, but now you want to know how far did I travel in 1 hour. So again, we can use our little arrows if we want. But what I want you to notice is really what we're doing is we're going to divide every single time. We're actually going to divide the top and the bottom by the denominator. Okay? So really, 24 divided by 24 is 1 hour. But I just want you to notice that basically every time we want to find a unit rate, we're dividing the top and the bottom of our fraction by our original denominator right over here, 24. So easy enough, 24 divided by 24 is 1 hour. And then of course over here, I can do 2,160 divided by 24. Okay, so you can do all those calculations. I'm not going to do the long division right now. You don't need to watch that. But I would end up with the answer of 90, which means on average on our trip, we drove 90 kilometers in 1 hour. Now, of course, sometimes we were on faster highways where you could go 100. Sometimes we were on slower highways where we were stuck behind a truck and you could only go 80. But on average, this was our unit rate because my denominator is 1. We went 90 kilometers in 1 hour. So that's an example of unit rate. Now we're going to get even more specific. So again, we started with ratios, then we went to rates, then we went to unit rate, and now we're going to go to unit price. So unit price is still a type of unit rate, but it shows the cost of one item. Now, I bet when you finish this math lesson, if you ask your mom if she figures out unit rates for things when she's doing groceries, the answer is probably yes. She may not use the word unit rate, but often when our moms or dads do groceries, they want to figure out what is the best deal. And sometimes that can be hard when you're comparing two different quantities. So here I have 12 eggs and I have 18 eggs. Obviously, the 18 eggs is more money than the 12 eggs, but how much are you actually paying per egg? This is when it's helpful to have a unit rate. So if I have, gotta get rid of my highlighter. So I'm just gonna rewrite my rate, which is a ratio down here, 4/12. Remember, I need to divide the top and the bottom by 12 because I want to know how much it is for one egg. Another way to think of it again, if this is how you prefer, it's totally fine. Divide by 12. What you do to the bottom, you must do to the top. So now we need to think, well, what's $4 divided by 12? Remember when you're setting up long division, the thing that you say first, $4 divided by 12, goes in the box. Or if you look back over here, this is really division, right? 4 divided by 12. Number on top goes in the box. So if I want to do 12 into $4 or $4 divided by 12, 12 does not fit into 4. So I'm going to put a decimal. Sorry, it's a little bit crowded on my iPad. Add a 0. 12 does fit into 4. It fits in 3 times. 3 times 12 is 36. And then 4, bring it down, fits in 3 times. And I'm quickly starting to recognize that I actually am going to end up with a repeating decimal. So what I'm going to do is I'm just going to round it to the nearest cent, which would be 0 and actually 33 cents because that 3 is repeating. So what I've actually figured out, I can put it up here. Again, sorry for the bit of a mess. I figured out if I buy a dozen eggs, it's 33 cents for one egg. Just going to erase my work here. So it's 33 cents for one egg if I buy a dozen. Now let's take a look if I were to buy 18 eggs. So same thing. I end up with, here's my rate, which is a special kind of ratio. I want my 1 to be on the bottom. So I'm dividing by 18 on both. So number on top goes in the box. Oops. All right, so then I can think, well, I got to place my decimal. 18 does not fit into 5, but 18 does fit into 54. And I believe it fits in 3 times. 3 times 18 is 54. And then I would place a 0. So what I should notice of what is the better rate. In this case, because I'm buying something, the better rate is the smaller number. So in this case, it is cheaper to buy the set of 18 eggs. Quite often, it's cheaper to buy the larger item or the one that's more in bulk. That's often why our parents like to shop at Costco, but not always. So when you start doing your own grocery shopping, it's important to look for the unit rate. Sometimes actually the little tag that tells you the price will tell you the price per egg or the price per 100 grams, but you should be able to do this yourself. So you know that it's actually cheaper to get 18 eggs. All right, let's take a look at another example with unit price. So remember when we talked about unit price, I talked about that the definition is the cost of one item. But you can also simplify that to something like the cost of, say, 1 liter. Okay, so we can also use unit price just to narrow it down. So here we have a 1 liter carton of milk, and it's $1.35 for that 1 liter. So I actually don't need to do any math on this one because I already have the unit price. I know the cost per 1 liter. But now if I look over here in Manitoba, we have milk jugs, which I much prefer. And we have a milk jug, and let's say it's $5 for 4 liters. Well, I want to know the unit price. I want to know how much is that then for 1 liter. So here's my rate, $5 for 4 liters. And I'm going to divide by 4 on both sides to get that 1 as my denominator. So then over here, I can do number on top goes in the box. 5 divided by 4. 4 fits into 5 one time. Remainder 1. So I'm going to place a decimal, 0, bring it down. Goes in twice. 8, 2, 0, and it goes in 5 times, and I get 0 at the bottom. So I've now figured out my unit price for my milk jug. And it is actually a bit cheaper. It's $1.25 for 1 liter. So you would say that this is the better rate, which is also the most cost-effective way to buy milk. Again, you can do your own calculations if you compare. Maybe your mom buys a carton, but maybe then she also buys the bag of milk that has 3 liters in it, like 3 small bags of a liter. It's definitely right now cheaper to buy the bags of milk compared to the cartons. But sometimes the cartons go on sale, and then it's actually cheaper to buy multiple cartons. So that's why it's good to be able to calculate the unit rate. All right, let's do another example. Earlier today, I was putting in a click and collect order, and I needed to order some pistachios for the meal that I'm hoping to cook tomorrow night. And it told me that the price was $3.63 for 50 grams. But I found that I could actually also order pistachios that were already peeled for me, and I wanted to compare the price. So the ones that was already peeled, it already told me the price and for 1 gram. So I want to figure out the unit rate for this one where I'd have to shell my own pistachios. So what I'm going to do is I'm going to divide by 50 on the top and divide by 50 on the bottom because I want that denominator of 1 gram. So let's see if I can squeeze in my long division here. Number on top goes in the box. Now I place my decimal. 50 does not fit into 3. It does not fit into 36, but it does fit into 363. In fact, it fits in 7 times. And then I get 13, bring down the 0. It fits in twice. 100, 30, bring down a 0. I'm right on the edge of my iPad here. And then 6. Oh, the 6 isn't going to show. Sorry about that. Oh, there it is. Okay. Now, grade 7, in your textbook, often when you're working with the unit price, a lot of the questions, it tells you to round to the nearest cent. So right now I figured out my answer was this. Okay, and here's my dollar sign. Please remember when you're rounding to the nearest cent, you need to look for the number that's in the penny spot. So we have the dollars, the dimes, and then we have the pennies. This is my target number, and remember the number to the right of it is my helper. It tells me 5 or more, raise the score, 4 or less, let it rest. So to round to the nearest cent, this 2 tells me to keep the 7 the same, and then everything else becomes a 0. So my unit price here is actually 7 cents per 1 gram. So then I can compare that to the cost of buying pre-shelled pistachios. The pre-shelled pistachios were definitely more expensive, but then I can make a decision. Is it only a little bit more expensive where it's maybe worth it so I don't have to sit and shell pistachios? So that's how you can do your grocery shopping or help your mom with it. All right, let's do one more question. Good to do a problem-solving example because you're going to be doing 2 of those in your textbook. So again, like my example from before, I used to work at Premier Printing where I made those agendas. On one shift, I coiled or put coils on 3,400 books in only 10 hours. But then my sister only coiled for part of the day. She often worked other jobs while she was at this factory. And she coiled 1,340 books in 240 minutes. So we want to know who coiled at a faster rate. So the first thing we need to do is we need to actually set it up as a rate. So I'm going to set it up. This is me. I did 3,400 books in 10 hours. And then we'll do my sister on this side, and she did 1,304 books in 240 minutes. Now, if we were in class, I would ask you, what do you notice about the denominator for each of these rates? And what you should notice is that they're actually different, okay? For my sister, we were talking about minutes, and for me, we're talking about hours. That's fine for now. We just need to keep it in mind. So let's start with me. If I want to know how many I then did in 1 hour, how handy, I can actually just divide by 10. Remember, when you divide by 10, you can just shift the decimal. So the answer is I did 340 books in 1 hour. That is the unit rate for me, 340 books in 1 hour. So now let's take a look at my sister. So notice that I pointed out that we're working with minutes. And because we want to compare, often we say apples to apples or the same thing to the same thing, we want to actually know how many books she did in 1 hour. We want to have the same unit rate or the same denominator. So what I'm going to do is I'm going to say, okay, well, the number of books that she did didn't change. But what I'm going to do is I'm just going to pause. I'm going to think, 240 minutes, how many hours is that? Well, I should know that there's 60 minutes in an hour. So 60 fits into 240 4 times. So actually my sister's rate is 1304 in 4 hours. Now the reason that's helpful for me is that now I can find her unit rate by dividing by 4 on each side. So I get 1 hour. And then I can do some long division. Long division is very annoying to do on an iPad because you run out of room very quickly. But we should get, let's see if I can squeeze it in. We get 326. So she did 326 books. So we're now able to compare the rates. And it shows that I was a faster coiler than my sister, which is a true story, but I also worked there longer than her, so I got good at it. So again, notice we're only able to compare that I'm faster because we made sure that we were both talking about 1 hour, right? Because if we had figured out how many books my sister did in a minute, it would probably be, I think, let's see, if she did 326 an hour, you could divide it by 60. It's too late at night for me to do the math right now. But it would, so let's say she maybe was doing 5 in a minute, for example, that wouldn't really help me compare to an hour because you might say, oh wow, she's definitely way slower. She's only doing 5, but she's actually doing 5 in a minute. Again, I'm just sort of estimating there. But my point is that you need to make sure if you're comparing rates that you have that same bottom number. All right, so make sure before you actually get started on your lesson that you already marked yesterday's lesson and did a few corrections. I know grade 7 that, in a sense, corrections could be really easy because you have the answers right in front of you. But the idea is to seek understanding. So if you mark your work and you get something wrong, go back and try it again and then double check your work again because that's the best way to learn. Corrections is actually when the most learning happens. And then after that, you're going to do a 2 or 3 question quiz just so I can get some feedback and know what we're struggling with and what we're good at so that I can adjust my lessons accordingly. Feel free to chat with me or call me if you have any questions. Have a good rest of your day.